Hi, I'm Sydney, and today I'll be talking about classifying systems of equations and determining the number of solutions. Later we'll be hearing from Aaron with our other objective, but I'll talk about this one first. Let's get started. Now it's time to look at equations that reflected what we learned today. Let's check it out. Okay, for our example of system equations, our two equations that we have is y equals 2x plus 6 and 3x plus y equals negative 9. Now in every system of equation, y has to be by itself. In this equation, it's right because y is by itself. But for this equation, negative 9 is over here. So we have to put everything on this side so that y can be by itself. And once you do all this, all the configurations, you keep y equals 2x plus 6 because it was already y by itself. But you change the other equation to y equals negative 1 minus 3. And that is what gives you y by itself. Now moving on to the graphing. To graph the first equation, you have y equals 2x plus 6. Now we all know, as from earlier, you have to use y equals mx plus b. Okay, so our slope is 2 and our y-intercept is 6. So we're going to start at 6 and go up 2 over 1. And that gives us our line, our first line. Now down here, right here, y equals mx plus b. Down here, you do negative 3 for our y-intercept, and you go down 1 over 1 to get our second line. Now this will be an example of a consistent independent system of equation because it has intersecting lines with different slopes and it has one solution. This is just one example out of many that this has. This is the final result. This is the final graph. And here you can look closer. The final graph. And this, once again, is an example of a consistent independent system of equations. Okay, that was only one of 3 systems of equations. Remember, there's also consistent dependent systems of equations and also inconsistent equations. The example you just saw was the consistent independent systems of equations. There's 3 total. That is it for this objective. This objective was 3-1, the second one. It was to classify systems of equations and determine the number of solutions. Now Aaron will tell you more about the other objective we had. Thanks.
I'm Erin and I'm going to teach you how to solve systems of equations by using elimination. In solving systems of equations by using elimination, your first step is to find the value of one variable. Our problem is 2x minus 5y equals negative 5 and negative 2x plus 8y equals negative 58. To find the value of one variable, you simply add the two equations together. 2x plus negative 2x cancels out. Negative 5y plus 8y equals 3y. And negative 5 plus negative 58 equals negative 63. Now all you have to do is simply get y by itself. And you do that by simply dividing by 3 on both sides, which leaves you with y equaling negative 21. Now the second step is to substitute the y value into one of the original equations to solve for x. I'm just going to take our first equation that we have, and I'm simply going to plug in negative 21 for this y. So I'm going to have 2x minus 5 times negative 21 equals negative 5. 5 times negative 21 is going to give me positive 105. And now all I have to do is get x by itself. Do that by subtracting 105 from both sides. And negative 5 minus 105 is negative 110. Divide by 2, and it leaves you with x equals negative 55. So the answer to this equation would be negative 55 and negative 21. Now the next set of equations that I'm going to show you are a little bit different from the ones that we just did. It is 2x plus 6y equals negative 8, and 5x minus 3y equals 88. Now these are a little bit different because, as you can see, 2x and 5x won't just simply cancel out, so you have to get it to where they will cancel out. And you do that by step 1, eliminate x by multiplying both sides of the first equation by 5 and both sides of the second equation by negative 2. So I'm going to take this one, multiply it by 5, and this one by negative 2. And you have to multiply it by negative 2 because to get it to cancel out, you must change the sign of one of the x values. So 5 times 2 equals 10x. 5 times 6y equals 30y. And 5 times negative 8 equals negative 40. Negative 2 times 5x equals negative 10x. Negative 2 times negative 3 equals positive 6y. And negative 2 times 88 equals negative 176. And now that you have this new set of equations, you can finish step 1 and simply just add these together to find y. (10x plus 30y equals negative 40). Negative 10x plus 6y equals negative 176. 10x and negative 10x cancel out. 30y plus 6y equals 36y. And negative 40 plus negative 176 gives you negative 216. Now to get y by itself, divide both sides by 36. And that leaves you with y equaling negative 6. Now step 2 is just like step 1 on the first set of equations we had. Substitute the y value into one of the original equations to solve for x. And once again, I am simply going to use just the first equation that we had. 2x plus 6y equals negative 8. I'm going to take the negative 6 and plug it in for this y. 2x plus 6 times negative 6 equals negative 8. 6 times negative 6 equals negative 36. Now all I have to do is get this x by itself. Add 36 to both sides. Negative 8 plus 36 equals 28. Divide by 2. And you get x equals 14. And the answer to this equation would be 14 and negative 6. And that's how you solve systems of equations by using elimination.